second part of our lesson. Same killer big idea, and we are going to learn how to determine pH or pOH if you have a weak acid or a weak base. And this is really where your AP concepts come into play. Keep in mind that weak acids do not ionize completely, as we mentioned previously, and so the concentration of weak acid is not equal to the concentration of proton. As a result, we need a different way to determine pH, or at least first how to determine proton concentration. Once you have that, it's still pH is equal to negative log of proton concentration. Ka and Kb values are unique, and they are found in your textbook on those pages designated, and you will need to refer to those tables to do some homework problems because they usually don't give you the Ka or Kb values. In your problems, you will always be provided with them. We'll talk about pKa and pKb a little later on, but it's calculated very similarly to pH, where you just do the negative log of the Ka or Kb respectively. When you're working acid-base equilibrium type calculations, previously we had reactions that only went in the forward direction because if it's a strong acid it ionizes completely and so it only goes forward. There are a few things you want to consider. You want to look at what the major species in solution are. For example, if you had a weak acid such as acetic acid, it doesn't ionize completely. Equilibrium lies far to the left. So the major species in solution in this case is the weak acid. These concentrations will be significantly lower than this one. You want to consider the dominant reaction. And again, the reverse reaction here. You've got an equilibrium reaction, but the reverse reaction is favored over the forward. These will definitely be equilibrium type reactions, and we'll talk later about reacting all major species as you go. That's a little bit later on in the chapter, and then we can solve for pH once we get proton concentration. There are a series of steps listed here. I'm not going to read through them because it's very tricky to follow until you know how to actually work a problem. We can refer back to these steps as we go, but I'll be walking through, pointing them out so that you can see how to solve these types of problems. Again, a weak acid or a weak base to determine pH. Our approach is going to be rice. We learned about rice in the previous chapter. R stands for reaction. I is the initial. C is the change. And E is the equilibrium. Woohoo! Wide awake, baby. One other thing to consider is the 5% rule. With the 5% rule, if the concentration of acid that is provided, and that's going to be the initial concentration, over the Ka, which is provided as well, is greater than 100, you can ignore the X that is added to or subtracted from the number because it's not going to affect the concentration overall. It's going to be less than 5% of the concentration, and I'll show you that piece in just a minute. First thing we want to do is calculate pH from Ka or Kb. All they're going to give you is this. It says determine the pH of a 0.250 molar propanoic acid. Ka is 1.3 times 10 to the negative 5. If they give you an organic acid, a Cu one, they'll give you the chemical formula. If they give you something like hypochlorous acid, you should know how to write that. Here's your reaction. Propanoic acid plus water in the liquid form, not included in a Ka expression, is equal to propanoate ion and hydronium ion. Initial concentration of the propanoic acid is right here. They don't tell you you have any product, so you assume it's 0. How do you know initially the reaction's going in the forward direction? Because you don't have any product. Subtract, add. Why did I subtract 1x? Coefficient of 1. And in this acid-base section, it's going to be easy because your coefficients will be 1.
Always. Why don't you do anything to water?
Why don't we include water?
It's
Liquid. So you can pretend it's not there. Uh-huh.
Why do you add water in the first place?
In the acid reaction, it wouldn't really make any effect. It's a hydrolysis type reaction, the addition of water. There would be water present because this is aqueous. With water, you'll generate hydronium ion instead of proton, which is typically more correct. What's really important is if you have a base, you better put the water in there, otherwise you're not going to see the hydroxide ion being generated. So I think it's just a good practice to get to do it.
It's like the conjugate acid.
This is an acid, so this would be the base generating this conjugate acid. Yeah. That 5% rule is what you're looking at right here. The molarity of the acid is 0.25 divided by 1.3 times 10 to the negative 5. That is going to be larger than 100, and that's what's shown right here. If it's larger than 100, you can pretend as if this isn't even here, and you're always going to be canceling that, making it very straightforward. Once you have that, the Ka value is provided right here. Both of these values are x. They will be the same, so you can just square it. And then 0.250 molar, we can eliminate this because x is less than 5% the molarity of the acid. It's not going to change this quantity. X squared is equal to this times this, and then take the square root and scribble on your paper. Don't forget to take the square root. It's the most common mistake kids make. Negative log of this will give you the pH. So all the steps are there for you. They're written here. List the major species, choose which species can produce proton, write the balanced equation, write the equilibrium constant expression, initial, the change, equilibrium, sub in, get rid of the minus x, and calculate. So it's all written there for you, although it's so expanded out. It seems like it's so many steps. It really is not that difficult. Let's do this first problem together from scratch so you can see every derivation piece, although most of you probably could do it without any assistance at this point. We want to know the pH, the concentration is 0.0100 molar, and the Ka is 1.1 times 10 to the negative 8, no unit for Ka. My approach is rice. I've got a weak acid, and that's hypochlorous. I'm going to react it with water in the liquid state. I'm going to generate conjugate base, and remember, acids will generate hydronium ion when the acid donates its proton to the base. Initial concentration here, nothing, nothing. What should we do next?
Subtract.
And it definitely is, because the Ka is puny. If the molarity of the acid over the Ka is greater than 100, you can do this, and it definitely is. When you have such a small Ka there, you've got 1 times 10 to the negative 2 divided by essentially 1 times 10 to the negative 8, and that fraction is huge compared to 100.
What happens if it's not?
It will be.
Oh,
Let it go. For your purposes this year, yes.
Okay.
So you can cross out x every time?
Uh-huh. The minus x, whatever you're subtracting from.
Cool.
For the acid-base section. Later on, it gets a little bit murky, so. All right, on your mini quiz that you will be seeing next week, you're going to get problems very similar to this. You've got to be able to do this Rice table. Your Ka is equal to products over reactant you've got 1.1 times 10 to the negative 8 is equal to x squared over 0.0100. So x squared is equal to 1.1 times 10 to the negative 10. X, which is equal to hydronium ion concentration, square root, square root, square root.
Really small.
How'd you go from that to the 1.1 times 10 to the negative?
Did it in my head. This is 1 times 10 to the negative 2
Oh,
times that.
Okay, you press.
Cross multiply. And that's 1.0 times
1, 2, 3, 4, 5.
no, it is. I was just looking at my sig figs, which are correct. So the pH is 5.00. Easy peasy, right?
Is there ever going to be a unit for pH or pH?
Nope. No unit for pH, pOH, Ka, Kb. No unit, no unit. Easy, right? We're going to do one with a base. Yep.
For the pH, did you just do that in your head?
Yep.
Okay.
But you don't get negative log of. But yeah, you can get some that you have to do in your head.
If it's on a part 1 question, will they all be easy numbers and stuff?
If they gave you like 3 times 10 to the negative 5, then you would know the pH is somewhere between 4 and 5, right? Because we did that, right? Okay.
3 times 10 to the negative 5 is between 4 and 5.
Didn't we do that at the beginning?
Yeah, but I was confused on 2, I just didn't ask.
All right, we'll do that again at the end then.
Okay.
I'll do it for you when we get something that's not 1 times 10. All right, the next example says, what is the pH for methylamine? Amines are typically bases. And they give you the Kb at 4.2 times 10 to the negative 4. Same approach, and this, Andrew, I think will really answer your question, your previous question, the importance of the water. So we're going to react this with water, but methylamine is a base. So does methylamine donate or attract? All right, so be very careful here. You're gaining a proton. You were neutral, now you're positive. And remember, with bases, you're going to have generation of hydroxide ions, and that's where the water comes into play. What's the initial concentration of methylamine?
0.2.
So we subtract, we add, and again, the 5% rule is in effect. We're going to get rid of this. The molarity of the base over the KB is greater than 100 here as well. Whenever you've got really wee KBs, and this one's not that small, but it's small enough, you're good to go. So here's a KB.
What do you call that ion?
This,
No.
this,
Yeah.
methylamine ion. Here's your methyl and there's your amine. Don't forget to take the square root or you're going to crash and
Do you square root both sides or just?
say what?
Do you square root both sides?
I usually multiply this and then take the square root of that. It's easier
How
for
do
me.
you know what to round it to? Do you have the
Yeah,
answer?
the KB was given in 2 sigs, so I stayed in 2. If you were in 3, it'd be all right.
So this is a base. So
This is a base, so we have hydroxide atoms, so what do we have to do?
Take the chlorine.
POH.
So it's the same process to find with KB that it is with Ka, except you have the extra step to find the pH.
Yes. And so what I do on your mini quiz is half of you get an acid, so I ask for POH, because half of you get a base and I ask for pH, so I want the same level of difficulty. Did you follow that?
Yeah.
Yeah. Okay.
One you're looking for pH, one looking for
Yeah, typically, you'd always be looking for pH, but with the bases, you just need to be careful. So the pH would be what?
11.963.
Fun, fun, fun.
That's a lot of work.
Once you get the hang of it, you can actually do these in a multiple choice fashion pretty easily, and you'll probably see 1 in May, like that on part 1.
Will these ever be a part 2?
Yeah. And then Faith, I want to answer your question right here. If you were approximating this in your head, the hydroxide ion concentration is 9.2 times 10 to the negative 3. This number is greater than 1, and so the pH is going to be 2 point something. If this is 1 times 10 to the negative 3, the pH is 3. But as this gets larger and larger, it gets closer to 2, and you can see that right there.
So if it was like, how do you know? I don't know.
You won't know exactly what this is, but you'll know it's between 2 and 3, and they'll give you a range choice in a multiple choice
So
section.
if it
You
was-
wouldn't have to discern between like 2.25 and 2.65.
But if it's like 10 to the negative 4, it's between 3 and 4.
Now be careful with that. If it's 10 times,
No, 9.2 times 10 to the negative 4.
right, but if it's 10, it really would be 1, right? Because you'd flip the exponent. So if it's greater than 1 and less than 10, it'll be 1 less than this with some decimals. So if proton concentration is 1 times 10 to the negative 5, the pH is 5.
That's whatever the exponent is.
If it's 1, if the proton concentration is 3.0 times 10 to the negative 5, and again, sloppy with Siggy Wiggies, here it would be 4 point something something, because it's going to be one less than this something left over. But they'll give you a range
Yeah, that's what I said.
on the exam. Yes.
I just changed the negative.
Well, you said 10.
I said 9.2 times 10 to the negative 4.
Oh, okay. Because if you had 10 times 10 to the negative 4,
Yeah, I know
you're
that's different.
okay.
I
Yeah,
said
you're good.
9.2 times 10 to the negative 4 is between 3 and 4.
Bingo.
Okay.
All right. So, with some practice, you will be golden at determining pH from Ka or Kb. Can't begin to tell you how important it is. Can't begin to tell you that if you can't do it as we go on through this chapter, buried. You want to be able to work this rice table a multitude of ways. In this case, you were given initial and given a Kb, and so you could get pH. Sometimes you'll be given pH, you can get this piece, you might be given this, and you can get the Kb. So there's a lot of different ways you can work it. We'll work it one more way today, and then we'll do some practice.
Does KB usually go with bases?
Always.
Always? And the Ka always goes with acid?
Yes.
Is that what the A stands for?
Yes.
Okay.
And we talked about it the other day,
But didn't you also
but it's
say,
been stressful.
Didn't you also say the other day that like Ka can be strong acid and Kb can be weak acid?
No.
It's only for weak acid?
No, I know what you're thinking of, and that's why I hated that example they did. HA to me is
yeah.
typically used for weak acid, but in that slide they used it for strong, and they used this for a weak acid. And that's why I told you I hated the designation that they used in the slide, but it's copyrighted, so I can't print over it. But yeah, not a good designation. All right, one last piece. Grossly similar. We're just going to work it slightly differently. You'll be golden with these once you practice, practice, practice. All right. So sometimes we can calculate Ka or Kb from pH and proton, or POH and hydroxide ion. Examples shown here, I'll walk you through, and then we'll do one from scratch, and then I'll give you one to do, and you'll see that you are able to do. Most of your mini quiz next week is on material we covered today. There'll be one additional piece, which we will hit first thing next time, because I don't want to rush through it. It's an important concept. And I don't think you want a quiz next week at the beginning anyway. All right, pH of a 0.64 molar solution of diethylamine is 11.98. We want to know Kb and then pKb, and pKb is just negative log of the Kb. You'll see where that comes into play later on, which is why I introduce it here. pH is given. Diethylamine is an acid or a base? Base. So instead of pH, we've got to get POH. Is it clear how we determine POH? Is it clear why we determine POH? Because diethylamine is a base. From that, we can get hydroxide concentration at equilibrium. So this was given, the initial amount shown here in red. We derive this very simply from the pH, POH. We can get hydroxide ion concentration. Why are these the same? Because the coefficient is the same. So these are the same. So now we can work it backward. Essentially, that is x, which we added to both positions. We're going to subtract it from here. Sometimes it doesn't change the value, sometimes it does. You will need to subtract that x out there since you already have it. Now you have all the equilibrium concentrations. Here's your Kb expression. Plug, chug away. Here's your Kb. Negative log of that will give you your pKb. Let's work the beginning part of this. This is from a different textbook. Let's work the beginning part of this very slowly. We'll worry about only calculating the beginning. It says hydroxylamine is a Bronsted base. You're starting with a 0.15 molar solution with a pH of 10.12. You want to calculate Kb and pKb. and then you want the percent ionization. Let's take a look. So the concentration of this initially is 0.15 molar. pH is 10.12. We want to calculate the Kb and the pKb. What do? Rice it up.
Where are you trying to find KB?
The-
And they give you pH?
Don't you have to find OH first?
You have to find pOH.
Yeah, we will, but we can rice it up.
Oh, okay.
What are the products?
Yeah, it's a thing.
Like, I don't know what it's called, but HONH3 plus.
Sounds good. What's your other product?
Hydroxide.
All right, so we've got this, and that's all we've got so far. So from pH we can get and from pOH we can get
The concentration of the hydroxide.
so where does that go? Here?
No, on the C.
The C.
I thought it went on that O.
Actually, it starts here. That is the concentration. Because you have 1x, it's also going to go
Okay.
here.
It's still 21.
And I don't know why. Yeah, I know it is. I just can't seem to write this quantity down properly. And I do know it is still this. All right. Now what? KB? Now on your mini quiz, I'm going to ask that you write the KB expression because they sometimes, if you get lucky, will have that very easy question on a part 2. This is a point you cannot forfeit. Don't do anything silly here. Make sure you've got charges where you need them. This is a point you must have. So KB is equal to,
1.1.
well, that's because I wrote it wrong so many times it finally incorrectly hit you.
No, I already did like the whole.
I know, but I kept writing it wrong. I don't know why. Dingbatitis, I guess.
And then you want to find pKb, right?
Yep, how do we do that?
Negative 1.
He's not writing it down.
So it's going to be 6 point something, right?
Yeah. Do you, with the pKb, do you do like the decimal place?
Yep.
Okay, so 9.6.
Yep, you got it. Not difficult. It requires practice. I can't emphasize enough the importance of practice. Some of your test scores were much better. You clearly put more time in doing practice problems and it made a difference. Some of you are still using degrees Celsius where you need Kelvin. Some of you don't know how to convert kilojoules to joules. Practice, practice, practice will eliminate all of those issues in most cases, unless you're just very uptight when you take your test. The one thing I do want to mention, and I can give you another practice problem, and I will, I wrote it out on the other class, and it's all the same problem as here because I worked it. I just didn't want to rewrite this. At the end of chapter 14, in your course outline, which is on Edline in the syllabus tab, if you don't know where it is, it means you've never done any homework in this class, which would explain some of the struggles. Do several Ka and Kb problems as well as simple pH calculations. You should be golden on this for Monday. If I dropped a quiz on you, you should be able to handle it. Your mini quiz will be next week. It will include one more section. And I do mini quiz in this chapter because the chapter is so long. If you don't keep up with it, you will be buried. Some years on the AP exam, acids and bases are hit so heavily, you can't afford not to have a solid understanding of it. From this second piece, you want to be able to write Ka expressions, solve them. You want to be able to determine pH, understand why they're needed for weak acids and bases. Understanding how to do this will set you up for most of the rest of the chapter, and it gets far more difficult as we go. Get the practice problems in this weekend so you have a solid understanding of the concept. Questions?